So today topic Equipartition theorem from unit 5, then thermodynamics and statistical mechanics. From question 1, then according to law of equipartition of energy, the average energy associated with each degree of freedom is, so most important question, repeated question, the answer is 1 by 2 kT. Okay, so this is the standard one. Okay, so the question number 2, the translation degree of freedom for monatomic gases molecule. So this is the most important. Okay, then monatomic gases. So then monatomic gases la what is the degree of freedom for translation? That should be a 3. Okay, for degree of freedom for monatomic gases. So option C is correct. Okay, so which is sometimes we have to find out the gamma values also. Okay, there should be a specific value. For monatomic ideal gases, the molar specific heat at constant volume. So then important word and constant volume. So then constant volume la, then already we have to say that from the previous question, then monatomic gases na, that should be a 3 above. In this question you have to see that here only 3 above, then CV is equal to then 3 by 2 R. Okay, so option A is correct. Okay, the ratio of specific heat for monatomic ideal gases. So most important monatomic. Up here the ratio of specific heat, this is the formula we have to write it down. That is then F plus 2 by F. Here F under the degree of freedom. Upon monatomic gases ke what is the degree of freedom? I already said that degree of freedom is 3. Upon we have to just substitute degree of freedom for monatomic gases 3 plus 2, then degree of freedom 3, then 5 by 3. Upon the correct option C is correct. Okay, so this is the most important one. Okay, so for diatomic gas at ordinary temperature, the number of active degree of freedom is approximately here diatomic gases. So then before question la monatomic gases for degree of freedom 3, here diatomic gases la then degree of freedom is 5. Okay, above which one is correct option? Here C is correct. Okay, so the same in these cases we have to find out that for the ratio of specific heat for monatomic gases, then similar way we have to find out the ratio of specific heat for diatomic molecules. Then F by 2 is equal to then F. Here diatomic gases like degree of freedom is 5, then 5 plus 2 by degree of freedom 5, which is equal to then 7 by 5. This is for ratio of specific heat value. Okay, you must remember. So the next one is a problem. Then calculate the average translation kinetic energy of one molecule at 300 Kelvin. So the Boltzmann constant is given. Okay, then how to solve? So already we have to given what are all the given. Then temperature T is given 300 Kelvin and Boltzmann constant, then K is equal to 1.38 into 10 power minus 23 then joule per Kelvin. Sometimes this constant or question. Okay, so you have to memorize those constant value. Okay, so what is the formula for this question? This is the important, then average translation kinetic energy. We have to use the translation kinetic energy that is equal to then 3 by 2 kT. Okay, so here then 3 by 2 is constant, then K is the Boltzmann constant into 1.38 into 10 power minus 23, temperature 300 Kelvin already given. Okay, just we have to substitute, multiple this one, then 1.38 into 300 panina, we have to get the answer 4.14 into 10 power minus 23, and the 10 power minus 23 அப்படியே வச்சுக்கலாம். Okay, just then 3 by 2 into 414 into 10 power minus 23, just substitute பண்ணிங்கன்னா we have to get the answer, then is equal to 6.21 into 10 power minus 21 joule. So the correct option C is correct. Okay, so then question number 7, find the here internal energy, that is the important internal energy of 2 moles of monoatomic ideal gas at 300 Kelvin. Here universal gas constant is given. So how to solve, what are all the given? So here number of moles, the number of moles 2, then temperature T is equal to 300 Kelvin, then gas constant, then R is equal to 8.314 joule mole inverse and Kelvin inverse. But what is the formula? We have to use that. Here you have to see that here T varade, then here gas constant R, then here number of the moles is N. So we have to use the formula for internal energy. But what is the formula for internal energy? Then U is equal to then F by 2, then N or T. Okay, here F is the degree of freedom. Here question given monoatomic gases. But what is the degree of freedom? F is equal to 3 for monoatomic gases. For diatomic, that should be a 5. Okay, but just we have to substitute in F equal to 5, then 5 by 2, where N is the number of the mole, into 2 into where R is the universal gas constant, then 8.314 into then temperature T, that should be 300. Okay, just we have to substitute everything, just we have to here we have to made one mistake. Okay, here that should be a degree of freedom is for monoatomic gases 3. Okay, then we have to substitute, then 2 into 8.314 into 300 இதெல்லாம் substitute பண்ணிங்கன்னா then we have to get the answer, then 4988.4. அப்போ then 3 by 2 into 4988.4, just we have to cancel out by 2, then 2494.2, just we have to multiple, then we have to get the answer, then 7,482.6 joule. This is the internal energy. So what is the answer? So we have to approximately take it as 7483 joule. So the option B is correct. Okay, so then question number 8, then according to equipartition theorem, the rotational kinetic energy contributes only as rotational energy. But the answer will be 1 by 2 kT per rotational energy. Sometimes linear non-linear கேட்டாங்கன்னா the answer will be changes. Okay, in this cases only rotation, so the answer is 1 by 2. If it is linear na we have to multiple by 2, then 2 into 1 by 2, then kT, just for kT varum for linear. So the non-linear na, that is we have to multiple by 3 into 1 by 2 kT, then we have to get 3 by 2 kT. This is for linear, this is for non-linear. Okay, important one. Okay, so question number 9, the internal energy of monatomic ideal gases. So already we have to write the formula here. Where we have to write it? Here is the formula for internal energy. So அதுதான் இங்கே கேட்டிருக்காங்க. Okay, அப்போ here internal energy we can write it as then U is equal to then F by 2 N RT. அப்போ monatomic ideal gases, what is the degree of freedom? 3. அப்போ then 3 by 2 N RT. அப்போ answer C is correct. Okay, so which motion does not contribute significantly for diatomic gases at ordinary temperature? Most important, it does not contribute for diatomic gases. Which one is does not? It should be a translation motion occurred, then linear motion occurred. So this one is wrong. Okay, so then C is not contribute. Not contribute for diatomic gases. So the remaining are contributed for diatomic gases. What all that? Then translation, rotational and linear motion. Okay, then most important one. Okay, so then remaining topic or question we discuss in the next classes. Okay, then moreover then if you join regular classes or test series, you must download the DPN Academy app from the Google Play Store. The link will be given in the description. If you are interested to join WhatsApp and Telegram, all the link will be given in the description. Okay, meanwhile then study material for UG and PG available. Okay, so if you want, contact WhatsApp number. Okay, thank you.